Welcome to Brain Awareness by Sam and Grace. Today we will be exploring the hindbrain and all its structures. The hindbrain consists of multiple critical structures, including the medulla, cerebellum, and pons. So let's begin diving into the medulla. The medulla is located just above the spinal cord and is responsible for controlling and regulating vital functions such as breathing, heart rate, blood pressure, swallowing, and digestion. The medulla also consists of 4 of our 12 cranial nerves, including cranial nerves 12, or known as the hypoglossal nerve, which controls tongue movement, cranial nerve 10, or known as the vagus nerve, which is the autonomic control of our heart, lungs, digestion, and much more, cranial nerve 9, or known as the glossopharyngeal nerve, which controls swallowing, taste, and salivation. And finally, it includes part of the cranial nerve 8, known as the vestibulocochlear nerve, which controls our hearing and balance. These nerves allow the medulla to control sensations from the head, neck, and muscles, and help control parasympathetic outputs as well. Damage to this area is life-threatening due to its control over these important functions. Damage to the medulla is most caused by strokes, brain degeneration, or even a traumatic sudden brain injury. Now, let's take a closer look into the pons' primary functions and responsibilities. The pons' primary function is relaying information like a messaging system. The pons actively acts as a bridge between different parts of the brain, significantly between the forebrain and the cerebellum. It lies ventral and anterior on each side of the medulla, allowing for axons from each side of the brain to cross to the opposite side of the spinal cord. Fun fact, that's why our left side is controlled by our right side. In addition to relaying messages, the pons play a role in our sleep and arousal regulation. Damage to the pons could vary depending on the extent of damage and area of damage. Most common symptoms related to damage to the pons include ataxia, which is loss of coordination, deafness, paralysis, vertigo, and much more. Lastly, let's focus on the cerebellum, which is a highly folded structure that's important for behaviors that depend on accurate timing. It contains the most neurons than any other part of the brain. The cerebellum is packed with a massive number of synapses and juggling tons of cool functions. Taking tips from the cerebral cortex, especially from the frontal and parietal lobes, and sending updates back to fine-tune your brain's cortical activity, as well as being the go-to for precision and perfect timing. The cerebellum is in the long haul in development. It's one of the first to start growing and one of the last to finish. Fun fact, the cerebellum is one of the first brain areas that alcohol crashes into, messing with your balance and coordination. Moving on to its functions. The cerebellum is the ultimate team player, always connecting with every part of the cerebral cortex to help out with almost everything your brain does, and essential for sharp attention. Talk about multitasking. The cerebellum lends a hand to all kinds of tasks, even ones that seem totally unrelated. While considering damage to the cerebellum, lots of factors are at play. Depending on where and how the cerebellum is damaged, it can mess with learning, memory, attention, visual spatial skills, language, recognizing emotions, or even social behavior. You might hear just fine, but figuring out how long it lasts becomes difficult. Picture this: if a puff of air to the eyes happens 1 second after a sound, someone with cerebellar damage might know the connection but can't time their blink to dodge the puff. Your timing is way off, imagine. Struggling to tell if one rhythm is faster than another, or missing the beat entirely when clapping or tapping along. Coordinating anything rhythmic, like tapping a beat, clapping, or judging movement speed, is very difficult. Anything that relies on aim or timing, accuracy is derailed. Even eye movements can go off track, making it hard to depict the right angle or distance. Making things worse, these effects can feel a lot like being drunk, clumsiness, slurred speech, and wonky eye movements. We hope you found this video fun and educational. Until next time, for more brain awareness.